In this video, we'll see how a Screwgauge works, how to take a reading by using Screwgauge, and at the end of the video, we'll see some problems based on Screwgauge. Okay. See, if you look at the Screwgauge, understand the main parts of the Screwgauge. This movable part is called screw, and this frame usually acts as a nut. Okay. So essentially, a Screwgauge is nothing but screw and nut arrangement. Screw and nut arrangement. Okay. Now a Screwgauge consists two scales. You can see the horizontal scale or this linear scale or pitch scale. All are same. Usually we call it as pitch scale. Okay. And this one is circular scale, also called as head scale. Okay. So this is screw. This entire part is nut, and this part, this is a stud. The gap between stud and screw can be known by taking reading on the screw gauge. Okay, usually you'll find the distance between this stud and this screw. Okay, this distance we can find. Means, for example, if I keep a cylinder here and tight it, then I can find the gap between these two by using the screw gauge, which is actually the diameter of the cylinder. Okay. And if I can keep this cylinder in the horizontal position, then I can find the length of this cylinder. Okay. You have to understand few things before taking the reading. Okay. So you can see there are some divisions on the pitch scale. Okay. You take the distance between two successive divisions. These two divisions. What is the gap between two divisions? That gap is called main scale division. Okay, main scale division, which is generally 1 mm, but it can be 0.5 mm sometimes or 2 mm. Okay, usually if they don't give, you can take this distance as 1 mm. Okay, this is one main scale division. And you count the number of divisions on the head scale: 0, 5, 10, 15, 20, 30, like that, 95, and these 5 together, 100 divisions. So number of divisions on the head scale or circular scale, 100, but it can be 50 sometimes, 200 sometimes. Okay, so you have to count the distance between these two, which is main scale division, and distance on the number of divisions on the head scale, which is 100 here. Okay, next part is pitch of the screw. Pitch of the screw. What is pitch of the screw? Look carefully. Look at this line. This is called index line or reference line. The horizontal line on the pitch scale is called reference line or index line. Okay. See what I'm doing. I'm turning this screw. When it turns by 360 degrees, means one rotation, the screw has advanced some distance. That distance is called pitch of the screw. If I turn for one more time, it has traveled 2 millimeters. Okay, so the pitch of the screw is defined like this. It is the distance traveled by the screw in one complete rotation. So in this case, in one complete rotation, it travels through 1 mm. 1 mm. Okay. So you understood some basic things, and then I'm writing those here. So screw gauge is used to measure what? Thickness or distances up to 0.01 mm. It can be less than 0.01 mm sometimes, or more than this. Usually it is 0.01. The screw and nut arrangement. How many scales? It consists two scales: pitch scale and head scale. What is pitch of the screw? Distance traveled by screw in one complete rotation. Okay. So pitch of the screw is also equal to what? 1 MST. I told you, if it turns from here to here, you will see the gap between them is 1 mm. Okay. So one main scale division. And I told you to count number of head scale divisions. That is, say, small n. number of divisions on the circular scale or head scale. N can be 50, 100, 200. Most of the times we'll have 100. Okay. So the least count of the screw gears. So what do you mean by least count? It is the distance, the least distance that can be measured by using screw gears. It is defined like this: pitch of the screw by number of head scale divisions, P by N. So generally, P, as I told you, P means this 1 mm. Okay. I told you 1 mm. Generally 1 mm. Number of head scale divisions, 100. So least count will be this much. Okay. So how to find the reading of the screw gears? Reading is nothing but, as I told you, distance between stud and screw. Okay. Reading formula: PSR plus HSR into least count. Now I'll tell you how to take PSR, HSR. Already we got LC. Okay. So for example, we kept an object here. Now I'll have to take reading from this. PSR. PSR means pitch scale reading. So whatever the divisions you are seeing here, that you have to take as pitch scale reading. So take it as 0, 1, 2, 3. Suppose you have a situation like this. Okay, 0, 1, 2, 3. 3 are visible. So 3 millimeters. 1, 2, 3 millimeters. And how to take a head scale division? See, one of the lines on the head scale is coinciding with this reference line. That you have to take as head scale division. H line in this case 30. You can see 30 is coinciding. Okay. So PSR will be 1, 2, 3 mm. Head scale reading will be, or head scale division will be 30. Okay. So PSR is 3 mm. Head scale reading, it's a division actually. Which division is coinciding? Least count we got 0.01 mm. That's how we take. How much? 3 mm. So 3.3 mm will come. That's the reading. Okay. But most of the times the instrument possesses error. So what is error here? See, look carefully. If no object is kept in between the stud and screw, you should read how much? 0. You should not give any answer. Means MSR should be 0, or sorry, not MSR. PSR should be 0. Means we cannot see any divisions here. 0. And the 0 of the head scale should coincide with the reference line. So in that case, my answer is 0. Okay. So when there is no object in between these two, or there is no gap between these two, I should get 0 reading. Okay. But some instruments, because of wear and tear, they won't show 0. Okay. Either they will show less than 0 or more than 0. Means, look at this. Look at this. So pitch scale reading is 0. No division is seen here. But the 0 of the head scale is not coinciding with the reference line, but something else, maybe some 92 or 93 is coinciding. Okay. That means even though there is no object here, we are getting some reading. Okay. Which is not correct. Okay. The instrument is having some error. That error is called 0 error. So the 0 error can be of two types. The 0 is above the reference line. Okay. And we cannot see any divisions on the pitch scale. Hardly it is visible. 0 is hardly visible. You cannot see. Okay. These two conditions are satisfied. Then it is said to be negative 0 error. Okay. 0 of circular scale lies above the index line. Second, 0 of pitch scale is less or not visible. 0 of pitch scale, no, not visible or hardly visible. Okay. In that case, error is said to be negative. What about positive error? Exactly opposite to this. You can see the 0 of head scale is lying below the reference line. This is 0 lying below the reference line. And the 0 of main scale or pitch scale somewhat visible compared to earlier. Okay, if these two conditions are satisfied, then it is said to be uh, positive zero error. Okay, so 0 of circular scale lies below the index line. This is index line, this is 0, lies below. And 0 of pitch scale, yeah, this is 0 of pitch scale, is more visible compared to earlier, correct? So that is what positive error. So how to find that error value? So error is nothing but reading of the screw case when stud and screw are in contact. Means keep the stud and screw in contact. Then whatever the value it is giving, that is our error. Okay. So if it is positive error, put plus in front of the reading. If it is negative error, put minus. Okay. For example, in this case, I'm finding error here. So I told you reading is nothing but, error is nothing but reading. Okay. So find PSR. Yeah, you can't see any divisions or 0 is barely visible. So PSR is 0. CSD. Okay, means circular scale division or head scale division, whatever it is. So which division is coinciding with 0 here? So you have to count from 0. 0, 1, 2, 3, 4, 5. 6th division is coinciding. So take it as 6. Least count anyway you got. So that is error. Okay. Coming to negative 0 error. Same. Put minus in front of the error or in front of the reading. PSR, you cannot see any 0 once again. So pitch scale reading is equal to 0. Okay. CST, which line is coinciding? Don't count like 40, 42, 43, 44 like that. So you have to count all the times from 0. Okay. 0, 1, 2, 3, 4, 5, 6, 7th line is coinciding. So 7th. Okay. Count CSD always from 0. Okay. Right. You got error here. Okay. So what is actual reading? For example, if we are using that instrument which is having error, okay, then to get actual answer, correct answer, what we have to do is you have to take reading of screw gauge by keeping the object. Okay, take reading, then do what? Minus of error. Okay, then you'll get actual reading. Okay, so let's see some questions, then you'll understand, or I'll show you one situation. Yeah, so whenever you're given this kind of diagram, okay, then you can tell the reading here. Okay, here I'm not calculating error. So you're given in the exam, you're given this kind of diagram. Okay, then you should be able to find the reading. Okay, assuming there is no error here. Okay, or they didn't give any information regarding error. So what is pitch scale reading? So 1, 2, 3, 4, 5, 6. Okay, 6 divisions are visible. So they mentioned here 1 MSD is equal to 1 mm. So pitch scale reading is equal to 6 mm. Okay, 6 mm. And what is uh, circular scale division? 75, 76, 77, 78, 79. 79 is coinciding. Okay, so circular scale division is 79. So you can get the answer by using those two. So reading is equal to PSR. How much? 6 mm. And 79th is coinciding CST, least count. So I didn't tell you least count. Okay. So we'll solve a problem based on it. Yeah. This question is given in JEE Means, one of the years. Okay, let's see the question. In an experiment to find out the diameter of wire using screw gauge, the following observations are noted. Screw moves 0.5 mm on main scale in one complete rotation. So earlier we have seen in one complete rotation, it has moved 1 mm. Here they mentioned 0.5 mm. Means from this, pitch is equal to what? Not 1 mm, but 0.5 mm. Total divisions. This is our N, 50. Okay. So from this, we'll find least count. Pitch by N, which is 0.5 by 50. I'll get again 0.01 mm. Okay. Now, main scale reading is given. How much? 2.5 mm. Also called as pitch scale reading. Both are same. Okay. And 45th division of circular scale is in the pitch line. Means it is coinciding with the index line. So CST or HSR sometimes, head scale reading, which is 45. Okay. Error of the instrument, they gave, no need to find, 0.03 mm, but they mentioned negative error, so put minus. Therefore, actual reading is equal to how much? Reading minus what? Error. Reading formula, MSR or PSR plus CSD into least count minus error. PSR how much? 2.5 mm. CSD have no units, it's just a number. Least count minus error itself a minus. So solve 2.5, 0.45, 2.95, 2.98 mm. That's the answer. Okay. Let's go to next question. Look at this. Screwgauge of pitch. So you're given pitch. Okay, they are using the screwgauge to measure what? Diameter of this tube. And this length is given 6.8 centimeters. Okay. They gave main scale reading or pitch scale reading. Both are same. 1.5 mm. And circular scale division, which is coinciding, is 7. Okay, screwgauge has 50 divisions on the circular scale. N is equal to 50. So again, least count is equal to P by N. So on solving, you'll get the same answer as before, 0.01 mm. Therefore, and they didn't mention anything about error. So let's find out diameter, means reading. I'm writing directly 1.5 mm plus 7 into least count 0.01 mm. So we'll get 2.2 mm. Okay, but that's not the answer. They're asking calculated curved surface area. Surface area of the cylinder, formula 2 pi RL. 2 pi R. Yeah, this is 1.57. So 1.57 mm. So this is a diameter. Okay, but I need what? Radius, right? So 1.57 by 2. Expressed in centimeters. So into 10 power minus 1 centimeters length. 6.8 centimeters. Okay, this 2 pi, 1.57 means pi by 2, so you get pi by 4 into 0.68 centimeters square. So usually pi square is 9.8 by 4 into 0.68 centimeters square. So solving, you will get 2.5 . So pi square is usually 9.8 by 2 into 0.68 centimeter square. So it's around 3.4. Okay. So that's your answer. Next question. Look at this question. Picture number of divisions on the circular scale for a given screw gauge of 0.5 and 100 respectively. So from that we can get least count, which is 0.5 mm, and number of divisions are 100. So we'll get 0.005 mm. So in this case, least count is less than 0.001. So in this case, it is actually more than so in this case, least count is less than actual value. Earlier we got 0.01 mm. Here we got 0.005. So the least count is reduced than earlier. So we can measure distances up to 0.005 meters. Okay, right. So remember, the least count is always not always 0.01. Okay, it can be less than that sometimes. Okay. Okay. And the screw is fully tightened without any object. The zero of its circular scale lies 3 divisions below the main line. Okay. Yes, this instrument is possessing error. So the zero, the circular scale lies 3 divisions below the mean line. Means it is which error? You can see the zero is lying below the reference line. Okay. Then it is positive zero error. How many divisions? 3 divisions they mentioned. So positive error. So anyway, no pitch scale reading. Circular scale divisions 3 and the least count 0.005 mm. So I'm getting error here, which is plus 0.015 mm. Right. The readings of the main scale and the circular scale given. Main scale reading is how much? 5.5 mm. Circular scale division is 48. Therefore, thickness of the sheet. Thickness formula. Reading with object minus what? Error. So reading MSR plus CSD into least count minus error. Okay. So MSR 5.5 mm, CSD 48, least count 0.005 mm minus error is plus 0.015 mm. So solve this. So 5.5 mm, 548 is 240. So we'll get a 0.24 mm. minus 0.015 mm. Okay, 5.74 minus 0.015. How much? So 5.735. So 725. Okay. Yes. That's how we'll find. Okay. So moving on to the next question. So easy question. Least count of screwgauge is 0.01 mm. They gave directly. Okay. When the faces touch each other, means they are in contact. Means main scale 0 marking is not visible. See, main scale 0 marking is not visible. And 96 division of circular scale coincides with the reference line. Okay, here 96 line. The 0 error of the screwgauge. See, main scale 0 marking is not visible. Main scale 0 is not visible. See, 0 of the pitch scale or main scale is not visible. Okay, then there is negative. And they mention 96 is a coinciding. Means you have to count CSD always from 0. So 0 to 96. How many divisions? 4 divisions. Okay. So it's a negative error with the main scale reading 0. So 96 is coinciding, means starting from 0, 99, 98, 97, 96 you can take. 4 divisions. Least count 0.01 mm. So the answer is minus 0.04 mm. Okay. That's all. That's how we'll find reading. So this is for your reference. Okay, see 0 error case. This is 0 error case. This is positive error. This is negative error. Okay, this is observed reading, so you can go through this. Right. That's all. Thank you.